In Chapter 10, we're going to switch gears again and talk about something totally different. We're going to talk about radicals. So remember from back in the day, radicals are things that look like this. Today we're going to focus on square roots, but you will have any number of roots in other chapters. Remember that symbol is called a radical, and whatever's underneath here is called a radicand. So by the end of this lesson, you should be able to describe the domain and range of a square root function, and then you should be able to graph a square root function. So right now, like I said, we're just going to focus on square roots. Usually we don't write this square in there, we just know that when we do this symbol it means square root. So we're going to graph things that have an x underneath this square root symbol. So here's our function. A square root function is a function that contains the independent variable in the radicand. This is your simplest square root function. For all x values that are not perfect squares, you can approximate them. So if you want to take the square root of 3, that's not a perfect square, but whatever that is in your calculator will work. You can graph a square root function by plotting points. Plot the least value in domain and several other points, and then join the points using a curve. All of your square root functions are going to look something like this. They are going to have a starting point, which we'll talk about how to figure that out in a second, and then they're going to shoot off. Now the reason that they have a starting point and they don't look like any other function we've done is because there is a restriction on our domain. So think back to beginning of the year. We talked about domain and range. Domain, remember, are your x values, or your independent variables, and your range is your y values, or your output. Domain is what we can plug in. So when we're talking about a square root function, we can't just plug in any number. Remember, we cannot have negatives under the square root. So in order to make sure that that doesn't happen, we have to restrict our domain. We can't just plug in any number. And because of that, it restricts our range, or what we can get out. So that's what we're going to do first, is we're going to find the domain and range of these functions. So in order to do that, you can follow a couple different steps. Remember, the whole point of this is we don't want whatever is underneath the square root to be less than 0. We don't want it to be negative. So what we're going to do is take whatever's underneath the square root, so in this case it's going to be x plus 3, and we want to make sure that this is always bigger than or equal to 0, because any number bigger than 0 I can take the square root of, and exactly 0 I can take the square root of, but I cannot take the square root of anything smaller than that. And then we get to solve this inequality. So if I get x by itself, this tells me that I can plug in any number that is bigger than -3 or exactly equal to -3. And this is our domain. And then to find the range, what you're going to do is you're going to take your smallest domain value. Yeah, let's wait to write that. So smallest domain value, and in this case, it's -3. And you're going to plug that into here. So your y values have to be greater than or equal to this square root thing. Plug in that smallest value and see what you get out. You get the square root of 0, which is just 0. So your y values need to be greater than or equal to 0, and that's your range. And this is your domain. So let's do the same thing with the next one. First thing you got to find is your domain. So remember, you take whatever is underneath the square root. So in this case, it's 2x minus 8. And all of this stuff needs to be positive or 0. So we're going to set it greater than or equal to 0. And then we got to do a little algebra. Divide everything by 2. So we get our x values need to be greater than or equal to 4. That's our domain. Now our range is what happens when we plug that in. So remember, you take your smallest domain value, which in this case is 4. and we're going to plug that in. So smallest domain is 4. And we need our y values to be greater than or equal to 3 times the square root, negative 2 times 4 minus 8. We'll do some algebra here. We end up with that square root of 0 again. I know the square root of 0 is 0, and 3 times 0 is just 0. So my y values, ran out of room, my y values need to be greater than or equal to 0, and that's my range. So the next skill is actually graphing them. So like the first slide said, you can graph them by just plugging in points, but that's not very effective. So let's talk about the points we're going to plug in and then how we can make this a little more effective. So remember, this is your simplest form, f of x, or you could have y. This is our parent function. That means every other function we get comes from this parent, this mom or dad function, however you want to think about it. When I plug stuff in, I can plug in anything greater than or equal to 0. So I plugged in 0. And then these numbers right here were very specific. I plugged in 0, 1, 4, and 9. And hopefully you're on the same page as me and get that I plugged those in because they're perfect square numbers. Now I totally could have plugged in 2 here, but then I would have to graph 1.2, and that's kind of hard to graph on here. So if I graph 1, 1, 4, 2, and 9, 3, I can see that it has this nice smooth curve here. So we talked about how we were going to find this starting point here. And with that, we need the baby functions. So every function starts with these letters here, A, H, and K, not existent. If I add an A, an H, or a K, it's going to do something to my function. The A right here is responsible for stretches, and it's also responsible for flips. It will stretch it if you multiply by a number bigger than 1. So if A is greater than 1, it makes it hop up more. And if A is less than 1 but bigger than 0, it makes it flatter. It flips it if A is negative. So I know this is all kind of jammed here. Flips it if A is negative. Stretches it depending on what your A looks like. So let's take a look at what that looks like on this next slide here. So this is the A part. This, remember, is your original function. Y equals the square root of x. Now if I put a bigger number out here, you see how it makes it like curve up more, where a number like 1/2 makes it flatter. So you can speculate that if I put a number like 3 in front of it, it's going to get even bigger. Y equals 3 root x. If I put something like 1/3, that's a little smaller, so it'll be a little flatter. The next letter that we can change is this H. Now this H is inside of the square root, and if you notice, it's x minus h. So this H right here is responsible for horizontal shifts. Remember that horizontal means left or right. Now if H is greater than 0, you're going to move to the right. And if H is less than 0, you're going to move to the left. Now be very careful with this because of this minus and negative here if you have something less than 0. If you see something like this, x minus h, oops, let's make a 4 here, x minus 4. The h value in here equals 4, so that means I'm going to move 4 spaces to the right. But if you see something like this, technically what you have is x minus a negative 4. That's how we get the plus. So h would be negative 4, and you'd have to move to the left. So if you want to, you can think of the fact that it's always backwards. If we move to this slide, we can see that here. This is affecting our h. Remember, this is our parent function, the one right here. If I have x minus 2 here, that moved it right 2 spaces. So everything just moved over 2, and we made it there. If it's x plus 3, remember h is a negative, so I'm going to move left 3 spaces. So if I gave you something like y equals the square root of x plus 4, you should be able to tell me that that moves it left 4 spaces. And the last thing we can change is this k value. This k value is responsible for the vertical shifts. And this one, there's no trickery. If k is positive, so greater than 0, you're going to go up. And if k is less than 0, you're going to go down. So if we go back to this slide here, this is my original function right here. This is f of x equals the square root of x. And if I give you the square root of x plus 2, when it's not inside of the square root, that means everybody's going to move up 2, and I can draw my curve. So if I had you graph f of x equals the square root of x minus 2, I'd go down 2 spaces, and then I'd make my curve. So let's put all of this together and actually graph something. So in order to find your starting point, you need to always pick up the h and the k values. So your start, actually let's write this back on this slide here. So your start or your vertex is always h comma k. So it's this value and this value. So if we go back to this actual problem, if I want to find my start, I need to get my h value and my k value. So remember, you always take the opposite sign here. So my start's going to be at negative 3. And then this one, negative 5. No opposite for that. So that's my starting point, negative 3, negative 5. And then, because there's no negative here, I know it's not flipped. A rough estimate of my graph would be that it just looks something like this. I want to make sure that that's what it is. I want to get a couple more points to plot. So let's talk about domain and range and a couple other points we could plug in. So the first thing we should find is our domain. Remember, we want all of this stuff underneath here to be greater than or equal to 0. So if I subtract 3 on both sides, I get that my x's have to be anything greater than or equal to negative 3, which makes this curve work, because that's telling me that my domain starts here at negative 3 and it has to be everybody over here, which is what we want. And then my range, remember, you take your smallest x value, which in this case is negative 3, and you plug that in. So I want all the y values that are greater than or equal to square root of negative 3 plus 3 minus 5 on the outside. So this gives me 0. Square root of 0 is just 0, and if you take away 5, you get negative 5. So my range is everybody bigger than negative 5, which again is true because that means it's everybody here. So let's find at least one more point in order to connect my dot that I just erased right here. It does not matter what you plug in, but there's going to be a couple things that are easy to plug in. So we plugged in, we had the negative 3. We've already plugged that in, and we know where that goes. Think of another number that's really easy to take the square root of. 1 is really easy to take the square root of. So what would have to go under here to take the square root of 1? Hopefully you said negative 2, because if I plug that in, I get negative 2 plus 3, which is square root of 1. And then the square root of 1 is 1, and I got to take away 5. So -2, -4 is another point. You can plug in as many of these as you want. 4 is another number that's awesome to take the square root of. So if I plug in 1 here, you end up with the square root of 4 minus 5, which is 2 minus 5, or -3. So over 1, down 1, 2, 3, and there is our curve. So you have 2 to find on your own. Make sure you find the domain and range, and then you can graph it. Make sure you write down any questions you have, and we can go over them together in class. Enjoy your night.